Hey folks, welcome back to part three of possibly the most important section this semester. We're going to continue with dosage calculations, and I've got a lot here. Uh, I, I I don't know how this might be a long one. We're just going to keep going, right? We're just going to do some practice problems, and um, as always, so I'll present the question. I'll read it the question, and then work through it. Right? And so you please pause and answer for yourself and then see the solution, right? So I'm going to go through this fairly quick, but I want you to go through it by taking your time and answering on your own, okay? Watching me do the question is actually not as helpful as you might think, right? You should work through the question first, and then you can check it by watching me do it, okay? But always try and attempt it on your own first. So when you get to problem, I'll read it and then pause it and then answer it for yourself and then come back and watch. Okay, okay, here's the first question. And this is actually a real personal question. This actually happened. My son, Dallas, when he was 2 years old, he broke his leg at a jump park. And we took him to the ER, and I overheard the doctor tell the nurse, 10 milligrams per kilogram Tylenol. That's what she said. 10 milligrams per kilogram Tylenol. And let's say my son weighs 30.0 pounds. So it's not exactly 30, but for the sake of the problem, let's say he weighs 30 pounds at the time. If this label here is the Tylenol administered, how much or how many milligrams should the nurse have given to my son Dallas? Okay, and I'm showing you the label here because the label has the concentration. Okay, so try this on your own. All right, we said 10 milligrams of Tylenol per kilogram of what? Well, this would be per kilogram of my son's body weight. Okay, so we have 10 milligrams of Tylenol per kilogram. And he weighs 30 pounds. So we need to convert that into kilograms, right? And then for every kilogram, we get 10 milligrams of Tylenol. Okay, so we have 30.0 pounds, starting with the known quantity, as always. We have to find the conversion between pounds and kilograms, and put kilograms on top. So you should have found that 1 kilogram is 2.205 pounds. And then we have 10 milligrams of Tylenol per kilogram. So pounds cancels out, kilograms of body weight cancels out, and we're left with milligrams of Tylenol. And that would be 136.0 milligrams. And then actually, that's not what was asked for, is it? It's milliliters. So there's one more step, and that's now using the concentration. So now we can multiply by 5 milliliters per 160 milligrams as given on the label. And they would have given him 4.25 milliliters. And if you look on the label, I think the dosage for a child is 5 milliliters, right? So the doctor was pretty spot on with the estimation there and the prescription. So 10 milligrams per kilogram. Okay, these are going to be questions from both types of problems, so IV and also oral dosages. Here's the next one. A doctor orders 25 milligram dose of lidocaine be given to a patient, and the drug is available at a concentration of 4 milligrams per milliliter. How many milliliters of lidocaine solution should you give the patient? So we will take 25.0 milligrams times 1 milliliter per 4 milligrams, and we get 6.25 milliliters. I think we've seen that question before. Okay, let's continue. Some of these will go quick. An order is given to infuse 250 units per hour of heparin, an anticoagulant. We saw that before. The IV bag supplied has a concentration of 50 units per milliliter. How many milliliters should the patient be given? At what flow rate in milliliters per hour should the IV solution be infused into the patient? All right. So pause and answer and come back. So what we want to find is milliliters per hour. So I will start with 250 units per hour to put hour on the bottom, and then 1 milliliter is 50 units, and units cancels out, so we get 5 milliliters per hour. So how many milliliters should the patient be given is 5 milliliters, and the flow rate set on the IV would be 5 milliliters over the course of an hour. An order is given to administer 20 milligrams of Atarax, an antihistamine, every 4 hours. The solution has a concentration of 2 milligrams per milliliter. How many milliliters should you administer to the patient every 4 hours? So we have 20 milligrams of Atarax, and we have a concentration of 2 milligrams per milliliter. How many milliliters should you administer? All right. 20 milligrams times 1 milliliter over 2 milligrams. So flip the concentration. Milligrams cancels out. And we get 10 milliliters. Okay. The every 4 hours part does not come in to play here, right? It's not actually like per hour or per 4 hours as a flow rate or anything like that. It's just telling us how often they're going to get that 10 milliliters, but it is not an IV, right? Okay, next question. An order is given to administer 187.5 milligrams of beta-pen VK, an oral formulation of penicillin. The suspension contains 125 milligrams of beta-pen VK in 5 milliliters of the solution, or I should say the suspension, really. What dose in milliliters of the oral formulation should be administered to the patient? So I have 187.5 milligrams beta-pen VK and 5 milliliters for every 125 milligrams. So milligrams cancels out. Left with milliliters, our desired unit, and we get 7.5 milliliters would be given. All right, let's keep rolling. Nipride is often ordered for patients who have experienced severe heart failure. A patient is receiving a nipride solution by IV at a rate of 60 milliliters per hour. The concentration of the nipride solution is 50 milligrams per 250 milliliters, D5W. How many milligrams of nipride per hour is the patient receiving? So now we want administration rate, right? How many milligrams per hour? And so we can look at the equations, or we can use the units to guide us. So work this on your own first and then come back and see 50 milligrams over volume to get milligrams on top, and then 60 milliliters per hour as the flow rate to get hours on the bottom. We're going to get the milligrams administered per hour here, and it would be 12 milligrams per hour. Next, all right. An order is given to administer 15 grams of lactulose, often used for treating complications of liver disease. The lactulose syrup has a concentration of 10 milligrams per 15 milliliters. What volume in milliliters of the syrup should be given to the patient? We've done a lot of questions like this, right? So we should be able to set this up now, in a fairly straightforward way. So we have 15 grams. I'm going to invert the concentration. So I have 15 milliliters over 10 grams. And my calculator says 22.5, but I pay attention to sig figs, and so we'll call it 23 milliliters. Okay. Digoxin is often used to treat a variety of heart conditions. For example, heart failure, atrial flutter, or atrial fibrillation. An order is given to administer 250 micrograms digoxin by IV every 5 minutes. The digoxin solution concentration is 2.5 micrograms per milliliter. How many milliliters should the patient receive every 5 minutes? So we have time showing up in the question, right? Every 5 minutes. But we know how much or how many micrograms we're going to administer every 5 minutes, and we're asked to find how many milliliters that is every 5 minutes. So the every 5 minutes part does not actually play into the calculation. And so, it seems like this is a lot more complicated, but this question is just like many that we've seen before. So it also happens to be micrograms, which is a new unit for these questions. It's just a small unit of mass with a metric prefix, but we can still find our answer in just the same way. So 250 micrograms, and we're going to invert the concentration for milliliters over 2.5 micrograms will give us 100 milliliters given to the patient every 5 minutes. Okay, same question with an added question at the end. So the answer that we got was 100 milliliters every 5 minutes. Now, what should you set the flow rate to in milliliters per minute? Okay, so now time comes into play. So now we want milliliters per minute, and so we can simply take the number of milliliters divided by the number of minutes. And we get 20 milliliters per minute. At this rate, how long will it take for 1 milliliter to drip? So this is a similar question as in the past, right? So we have volume per time. Now we want time per volume. So we can flip it to say 1 minute over 20 milliliters. And that's going to give us a fraction. So let's flip it to seconds. 60 seconds per minute will tell us now that it'll take 3 seconds per milliliter to drip. All right, one more final question here. This is the last one I got for you. Vistaril, an antihistamine, has a concentration of 25 milligrams per 5 milliliters. If 12 milliliters of the suspension are given to the patient every 3 hours, what was the dosage ordered? Okay, what was the dosage ordered is asking us how many milligrams were you asked to give the patient? Right, so now we can see 12 milliliters times concentration. And we know that because milliliters cancels out. We want milligrams on top. And the order would have been for 60 milligrams to be given every 3 hours. All right, so that wraps this up, right? Really, this whole section was just sample practice problems. But we did a lot of problems. Okay, so hopefully you had a chance to answer them all for yourself. And there's more practice in the book, of course, on sapling as well. So I encourage you to please take the time to practice these kinds of problems. As you can see, the questions that can be asked are nearly unlimited, but the way that you go about solving them uh, are only few, right? Once you kind of notice that we repeated the same basic uh, procedure and steps in multiple times, in different questions, in different ways, you'll see that really practicing solving these is really helpful. Okay, so we'll leave it here for 8.4, and in the next section, we will look at dilution equations and how to take a concentrated solution and quantitatively dilute it. As always, let me know if you have any questions, and we'll see you next time.